Hi guys, so today we'll be solving GFG POTD. In this question, what they are saying is they have certain landmines in this matrix, okay, and what they are saying is you have to find a path in between the first node and the last node. I mean the first column and the last column. If their path exists, then you can definitely give that distance. For example, this is a path that exists, right? This is a path that exists. Now there is one catch to it that the you cannot take the path which is around this particular mine. Okay, so you cannot take this, you cannot take this, you cannot take this. Again, this the up, right, up, left, right, and bottom. These paths you cannot take. Okay, for a landmine, for any of the landmines. Correct? So now this is one of the paths that you can take. What is some other path? Maybe this is some other path that you can take, right? So what you have to do is there will be such several paths, right? There will be such several paths. So you have to take the minimum distance of all of this. Okay. So for example, let me show it here. If I take this path, let's say, okay, what is the distance that I travel? So that is 1, 2, 3, 4, 5, 6, and 7. Okay, so I travel out 7. What if I travel this distance? That is 1, 2, 3, 4, 5, 6. That is 6. Okay, and you can travel all the paths. You can see all the paths, and the minimum distance that you will get is 6. Okay, so this is what you have to have as an output. So your goal is to reach from any node from here to over here. Now there might be cases that you will not be able to reach to the node. What may happen is you also have a mine over here, so you will not be able to cross, right? So if you're not going to able to cross, that means you have to return a -1 as an answer. Okay, so I will be solving this problem using BFS approach, okay, rather than DFS. And the reason being is that they have asked for the shortest path, okay, for the shortest path. So I will tell you why I will be applying BFS. So first, let's just get clear about the landmines. Okay, so here I have a landmine and it is not safe. So first let me just mark all the nodes which are not safe. Okay, so by marking, what I mean is this is a landmine, right? So for all of its neighbors, it is not safe, right? So what I will do is I will mark them as -1, -1, and -1, and even this guy as -1. Okay, let us do that for this 0 also. Okay, and let us do that for this 0 also. Okay, so all of this -1 indicates that these nodes are not safe to travel. Okay, so they are of no importance to us right now. So let me just get rid of them. Okay, they are of no importance to us. So our goal is to reach from the first column to the last column. How will we do that? See, the very first thing is I will be using BFS. So this is a multi-source BFS. That means what I will do is I will add all of these nodes which are there in the BFS. Okay, so I will start my BFS with all of these nodes. Why would I do that? Because all of these nodes are at a distance of 1. Okay, they are at a distance of 1. You can see that this is a distance 2. You can see that this is a distance 3. You can see that this is a distance 4, 5, and 6. So that is the logic, right? So what I will do is I will go and mark all of these nodes as 1, as distance 1, and also I will mark them as visited. Okay, so I will mark them as visited. Okay, now, in the next iteration, so let me just go like, these are my indices 0, 1, 2, 3, 4, and again I will have 0, 1, 2, 3, 4. Okay, so this is the node 0, 1, and for 0, 1, I have a distance of 1. Okay, similarly, sorry, for this is a 1, 0. Okay, this is a 1, 0. So for 1, 0, 1, for 2, 0, 1, for 3, 0, 1, for 4, 0, distance is 1. Okay, in the next iteration, in the next iteration, I will mark all the reachable nodes as 2. How will I do that? So I will take this first element out. I will take this first element out. Okay, and I will check its distance. So for 1, 0, are there any neighbors which are that we can mark? See, above there is a mine. Here also there is a bomb. here if you go, this that is already visited, so there is nothing to be added, right? So just we will not take any action. Take 20 out. If I take 20 out, what would that mean? I want to check its neighbors, right? Now this is already visited. The upper one is also already visited. We will not, will not touch it. But you can see that this is a distance, right? So this is there is a neighbor over here. So its distance we will mark as 2. Okay, like we will take this one and we will mark it as +1. That will be 2. Okay, what does that suggest? What does that suggest? That means that this element right here is actually reachable from the first column minimum at by a distance of 2. Okay. Now this is the reason why I chose BFS, because in DFS you will definitely reach from here, but you will also reach from here. Now again you will have to take the minimum of all of those, and then it will, the code will be very complex for you. So that is the reason BFS is good. Okay, because in each iteration, when I'm marking a particular node as visited, I can say with 100% confidence that 2 is the node, or 2 is the best distance. Okay, I would have not got at this particular node in a distance less than 2. Okay, so that is what I am rooting for. Again, in the second iteration, okay, again I will take, so this is 2 1, right? So I will push this 2 1, and I will also push its distance. Okay, now similarly here also you can see I will push. Okay, here also you can see. Now this guy will call this guy, and it will say, yeah, that you are at a distance of 3. Now this, it will say that you are at a distance of 3, 4, 5. Okay, 6 and 6, right? Now check here, you have reached over j is equal to c minus 1, which is the last column. So when you reach it, I can directly return this particular distance, right? And I claim that this distance is actually the minimum distance. Why? Because I had already told you over here. Whenever you are at any particular node, and in BFS, whenever you are marking that node, that means that that is the minimum distance. Okay, you are processing any node, that means, or popping any node from the queue, that means it is the minimum distance. Okay, so that is the reason why BFS is usually used in shortest path finding algorithms. So that is the thing. I mean, that is the whole approach, or how would we solve this this problem. Let us look at the code. The code is pretty simple. So first, what will I do? So the very first reason is I will pre-process the matrix. So here, if you see, I'm just going through each and every element, and if my matrix is 0, I will mark it as -1 and all of its neighbors as also -1. Now, have I made the neighbors? Here you can see these two lines, right? So I've taken these two arrays, and firstly, it will be like I plus delta x and j plus delta y. So I plus 1 and j, I minus 1 and j, I and j plus 1, I and j minus 1, like this. So these are all the four neighbors, right? And if these four neighbors, like the indices of these four neighbors, are inside the range, okay, that means the I is not crossing the row and the j is not crossing the column, that means I will mark that node as -1 because it is present, near the 0. Just add this into 0. So this is my unsafe node. Okay, now that is done, I will start my BFS. But before I start my BFS, I have to take all of the first column elements and push it into the queue, okay, with a distance of 1. So this is the distance of 1, and this is the column. And I will also mark them as 2. This is a standard BFS algorithm, okay. So again, in the queue, I have this distance I and j, and I will try to pop that node. But before I pop, what I can see is if j is equal to c minus 1, if I am at the last column, whatever distance that I have got over here, that is my minimum distance. Okay, but so let's say if I'm not there at the last column, then I will pop from the element, and again for that element, that is for this particular element, I will go against all the neighbors. Okay, I will check all the neighbors again, if all the neighbors are in the range or not, and if they are not -1. Okay, simply ignore the nodes which are which are not safe. And if the neighbor is already traveled, then you cannot offer it a better path, right? Because this is BFS, you cannot offer it a better path. So do not try to go, do not try to offer that path. If someone has already been processed, that means it has a better distance than you that you could offer. So just don't go over there. So if that node is not visited, then you can offer it a path. Okay. So what you will do is you will take it as visited, and then you will push it with a +1 distance. Whatever you had a distance, now you are that node is your adjacent. So you will offer it whatever distance you had till yourself +1. Okay. So that is the whole algorithm. Okay. And let's say that you did not reach the column and the becomes empty. So in that case, you were not able to reach from first column to the last column, and that is the reason by default I am returning a -1. Okay, so I will submit this code and we will see how it works. So it has passed almost all the cases, right? So yeah, so this will take order of order of R into C time, correct? How many number of rows you have and order, how many number of columns you have. And talking about the space, yes, definitely we are using this visited space, right? But if you see, R and C are in the range of 1 to 1000, right? So that is constant. This is 1000, which is constant. So that is why we also have the auxiliary space of order of 1. Okay. So that is the whole code. Thank you.
जैसे बारिश की बूंदों में चलता मैं हवा हूँ जो बूंदों से पूछेगा है कहाँ वो जहाँ जो